Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0711, indicates an issue with the continuously variable transmission, CVT, temperature sensor in Honda Civic models from 2011 to 2015. This sensor is crucial for monitoring the temperature of the continuously variable transmission fluid, CVTF, ensuring that the fluid remains within an optimal range for transmission performance. A failure in this sensor or its circuit might lead to an inaccurate temperature reading, which can adversely affect transmission functionality and overall vehicle operation. This DTC reinforces the importance of proper electronic circuits as the root cause of the problem, dismissing any mechanical failure within the transmission itself. Thus, understanding the role and functionality of the CVT temperature sensor is key in resolving this issue effectively, as the temperature sensor plays a central role in regulating the operation of the CVT. The following troubleshooting steps will guide through logical assessments and checks pertinent to rectify the DTC P0711. The DTC P0711 specifically pertains to a malfunction of the continuously variable transmission, CVT, temperature sensor, which is responsible for assessing the temperature of the CVTF. The sensor is typically mounted on or near the transmission case, where it can accurately gauge the temperature of the fluid within. If this sensor fails, it can send incorrect data to the powertrain control module, PCM, leading to erroneous decisions regarding transmission behavior. This sensor's readings are vital for preventing overheating or underheating issues, which can damage the transmission system. Accurate temperature measurement helps in optimizing the transmission shifts and performance, ensuring that the vehicle operates efficiently under varying conditions. When diagnosing this error, keep in mind that the circuit's integrity is crucial, since this code strictly signifies an electrical problem, eliminating mechanical faults as a potential cause. The potential causes for DTC P0711 are primarily centered around the electrical circuit of the temperature sensor. A problem within the sensor circuit could include damaged wires, poor connections, or corrosion, which can lead to erroneous readings. Additionally, a faulty CVT temperature sensor itself may also yield incorrect data, thus contributing to the DTC being triggered. Software-related issues within the PCM could further complicate the situation. If the PCM is outdated or possesses bugs, it may misinterpret sensor readings, affecting overall functionality. It's crucial to methodically assess each of these elements to identify the root cause effectively. Each cause requires a specific set of troubleshooting steps to isolate and rectify the error, while ensuring that all electrical aspects are thoroughly checked before moving on to component replacements. The most common symptoms associated with DTC P0711 include noticeable transmission performance problems, such as slipping or delayed engagement of gears. The CVT might not respond appropriately under acceleration if the temperature readings are inaccurate. Furthermore, drivers may experience unwanted dashboard warning lights, indicating an issue with the transmission system. In more severe cases, these issues might escalate to transmission overheating, which could have dire implications for the vehicle's operation. Additionally, finding that the CVT fluid temperature appears abnormal could lead mechanics to investigate further into why there are misreads. These symptoms collectively emphasize the importance of the CVT temperature sensor in overall vehicle performance and underline the necessity for prompt diagnosis and repair upon detection of this DTC. To begin the troubleshooting process for DTC P0711, start by turning the ignition switch to the on position, which powers up the vehicle's electrical systems without starting the engine. Utilize the Honda Diagnostic System, HDS, to check the continuously variable transmission fluid, CVTF, temperature in the data list. It's essential to verify whether the CVTF temperature shows a reading of 14 degrees Fahrenheit, minus 10 degrees Celsius, or below. If the temperature indicates this alarmingly low level, it is necessary to proceed to the next step in the troubleshooting process. Conversely, if the temperature reading is higher, further investigations must target potential issues not directly linked to the sensor, but rather towards the PCM or the transmission fluid itself. This first step is critical, as it helps set the baseline for further diagnostic actions and can swiftly point to the immediate area requiring further assessment. The second step in addressing DTC P0711 involves a detailed analysis of the transmission fluid temperature sensor after the engine has warmed up to its normal operating temperature. To conduct this check, first, start the engine and let it idle until the engine coolant fan cycles on at least twice, indicating that the engine is adequately heated. With the HDS, again check the CVTF temperature in the diagnostic data list. If the reading is still at 14 degrees Fahrenheit, minus 10 degrees Celsius, or below after the engine has warmed up, the next course of action is to replace the transmission fluid temperature sensor, as it is likely faulty. On the other hand, if the temperature registers at 14 degrees Fahrenheit, minus 10 degrees Celsius, or higher, it suggests the sensor might be functioning correctly. This step is vital to pinpoint if the problem lies with the sensor or if it requires a more extensive diagnosis of the transmission control mechanisms. In the third step, verification of the problem is crucial by measuring the CVTF temperature again using the HDS. The primary focus should be whether the CVTF reading indicates 230 degrees Fahrenheit or 110 degrees Celsius or higher. This high temperature signifies that a serious malfunction has occurred within the transmission system. If this threshold is crossed, the failure is confirmed, and you should proceed to the next step to address the underlying issue. However, if the temperature reading is below this threshold, you will need to take a different approach, which involves updating the PCM software if it is outdated or substituting in a known good PCM for further analysis. If the DTC clears upon updating or substituting, it signifies that the PCM may have been the root cause, prompting a complete resolution of the issue. The final step requires checking the CVTF temperature while the engine has cooled down to a safer operational level, specifically until the engine coolant temperature reads 122 degrees Fahrenheit, 50 degrees Celsius, or below. Utilize the HDS once again to determine the CVTF temperature. If the reading indicates 230 degrees Fahrenheit, 110 degrees Celsius or higher, it implies an issue with the transmission fluid temperature sensor, warranting its replacement. Conversely, if the CVTF is at or below this level, the sensor is functioning normally, suggesting the fault might be intermittent or temporary. At this stage, if any abnormal temperature fluctuations were observed during testing, you may want to revisit the PCM updates and assessments. Ultimately, this step aims to clarify whether root problems lie within the sensor or the electronic systems governing it, ensuring a comprehensive troubleshooting experience. Upon completion of the troubleshooting process and any necessary repairs, it's crucial to conduct a final verification to ensure optimal functionality. First, confirm that the replacement or repaired CVT temperature sensor is operating correctly by checking the live data again through the HDS. Following that, ensure no additional Diagnostic Trouble Codes, DTCs, have been triggered during the repair process, as these may indicate other underlying issues. Once both the sensor is confirmed functional and no DTCs are present, it is advisable to take the vehicle for a test drive. This allows for the observation of the vehicle's performance under dynamic conditions, ensuring that the correction of the P0711 DTC has addressed the issue effectively. Proper verification is key in ensuring that the problem does not persist and that the vehicle operates reliably. Preventive maintenance is essential to mitigate future occurrences of DTC P0711 and ensure the longevity of the CVT system. Regular checks of the CVT temperature sensor can help catch issues early before they lead to larger problems. This can involve inspecting the sensor's wiring for any signs of wear, corrosion, or damage. Additionally, ensuring that the powertrain control module, PCM, software is always updated will help maintain compatibility with the various sensors and systems within the vehicle. Maintaining proper levels of CVT fluid is critical as it extends the lifespan of the transmission system and aids in keeping the temperature within an optimal range. Essentially, dedicating time to regular maintenance will provide peace of mind for both the vehicle's reliability and the driver's experience. In conclusion, DTC P0711 signals a critical issue with the CVT temperature sensor within the Honda Civic models from 2011 to 2015. Understanding the role of this sensor in maintaining vehicle transmission performance cannot be overstated. Consistent and thorough diagnostics, combined with prompt corrective actions, are essential to resolve this issue effectively. Furthermore, regular vehicle maintenance, including sensor checks and software updates, plays a vital role in preventing the recurrence of this DTC. Ultimately, addressing the root cause, coupled with adherence to preventative strategies, will lead to improved vehicle reliability and operational efficiency, ensuring a satisfying driving experience. Please like and subscribe to the channel. See you